Antonie Philips van Leeuwenhoek was born on October 24, 1632, in Delft, Netherlands, to a modest family. His father, Philips Antonie van Leeuwenhoek, was a basketmaker, and his mother, Maria de Meer, was the daughter of a textile merchant. Despite his humble beginnings, Leeuwenhoek's intellectual curiosity and observational prowess would eventually make him a pioneer in the field of microbiology. Education and early career. Leeuwenhoek's formal education was minimal. He attended a local school in Delft, where he received a basic education. In 1650, at the age of 18, he moved to Amsterdam to work as an apprentice in a merchant's office. After completing his apprenticeship, he returned to Delft, where he worked as a draper, managing his own shop. Passion for microscopy. Leeuwenhoek's interest in microscopy began in the 1670s. His fascination was sparked by the discovery of the work of Robert Hooke, an English scientist who had published Micrographia in 1665. Hooke's book, which described observations of various natural objects through a microscope, inspired Leeuwenhoek to construct his own microscopes. Microscope innovations. Leeuwenhoek is best known for his pioneering work with the microscope. Unlike the compound microscopes used by his contemporaries, which employed multiple lenses, Leeuwenhoek's microscopes were single-lens devices. His microscopes were remarkably simple but highly effective. They consisted of a single glass lens mounted in a metal frame, with a small, finely tuned lens held in place by a simple screw mechanism. Leeuwenhoek's lenses were ground and polished to achieve high magnification, allowing him to observe objects as small as 1 micrometer in size. He produced a series of lenses, each with different magnifying powers, ranging from 50x to 300x magnification. His lenses were so well crafted that they provided clear and detailed images of microscopic life. Scientific discoveries. Leeuwenhoek's observations and discoveries were groundbreaking. In 1674, he described his first discovery of microorganisms, which he referred to as animalcules. Using his microscopes, he observed and documented a variety of microscopic organisms, including bacteria, protozoa, and spermatozoa. These discoveries were published in a series of letters to the Royal Society of London. Bacteria and protozoa. In 1676, Leeuwenhoek described the first bacteria, which he observed in a sample of pond water. He noticed tiny, motile creatures, which he called animalcules, and was able to distinguish between different shapes and sizes of bacteria. His work also included the observation of protozoa, such as paramecia and amoebae. Spermatozoa. In 1677, Leeuwenhoek made another significant discovery by describing spermatozoa. He observed the structure of sperm cells in various animals, including humans. His detailed observations provided crucial insights into the process of reproduction. Blood cells. Leeuwenhoek also made notable contributions to the understanding of blood cells. In 1674, he observed and described red blood cells and their shape and movement in the bloodstream. His observations laid the groundwork for later studies on blood physiology. Muscle striations and capillaries. Leeuwenhoek was one of the first to describe the striations in muscle fibers and the network of capillaries in the body. His observations of the microscopic structure of tissues contributed to the understanding of anatomy and physiology. Correspondence with the Royal Society. Leeuwenhoek's discoveries were communicated to the scientific community through a series of letters to the Royal Society of London, where he corresponded with prominent scientists such as Robert Hooke and Henry Oldenburg. His detailed and often enthusiastic descriptions of his observations captivated the scientific community. In his letters, Leeuwenhoek provided meticulous drawings and descriptions of the microscopic world. Although he did not have formal scientific training, his observations were highly accurate and often preceded the work of other scientists. His contributions earned him the recognition and respect of the scientific community, despite his isolation from formal scientific institutions. Later life and legacy. Antonie van Leeuwenhoek remained dedicated to his work throughout his life, continuing to make observations and improvements to his microscopes. He was an independent researcher, relying on his own resources to fund his scientific pursuits. He never sought formal academic recognition or financial gain from his work. Leeuwenhoek's contributions were widely recognized during his lifetime. He was elected a Fellow of the Royal Society in 1680, and his work had a lasting impact on the field of microbiology. His meticulous observations and pioneering techniques laid the foundation for the study of microorganisms and cellular biology. Leeuwenhoek's influence extended beyond his lifetime. His techniques and discoveries inspired future generations of scientists, including Louis Pasteur and Robert Koch, who furthered the understanding of microorganisms and their role in disease. Antonie van Leeuwenhoek passed away on August 26, 1723, in Delft, Netherlands, at the age of 90. His legacy endures through his groundbreaking contributions to microbiology and microscopy. His work paved the way for the development of modern biology and the study of the microscopic world. Conclusion. Antonie van Leeuwenhoek's life and work represent a remarkable journey from a humble draper to a pioneering scientist who revolutionized the understanding of the microscopic world. His innovative microscopes and keen observations laid the foundation for modern microbiology and cellular biology. Despite his lack of formal scientific training, his contributions had a profound and lasting impact on the field, and his legacy continues to inspire scientists and researchers around the world. Thank you for watching. Please subscribe our channel.